Hello everyone, welcome back to the channel. If you have been hearing terms like Langchain, AI agents, retrieval augmented generation, memory tools and LLM applications but don't know how they all fit together, then this video is for you. In the next hour, we are going to build a solid understanding of Langchain from the ground up. We'll start by understanding why LangChain exists, then explore its core components, learn how to connect language models with external tools, understand prompts, chains, retrieval, memory agents, and finally build a simple AI application using everything we have learned. This is not just another theory video. My goal is to help you understand the concepts behind LangChain so that after watching this video you can start building your own AI applications with confidence. Let's begin. Chapter 1 is what is LangChain. Before understanding LangChain, we first need to understand the limitation of a standalone large language model. A language model such as GPT can answer questions, summarize text, generate code, and assist with writing. However, by itself, it does not automatically access your files, search the internet, query databases, call APIs, or perform actions like sending emails. Suppose you ask an AI what are the latest stock prices. Without additional capabilities, the model only knows information that it was trained on or information explicitly provided to it. It cannot fetch live stock prices on its own. Now imagine asking, read my PDF, summarize it, search today's news about the company mentioned inside, and email me the summary. A standalone language model cannot complete this workflow by itself. This is exactly where Langchain comes in. Langchain is an open source framework designed to help developers build applications powered by large language models. It provides building blocks for connecting language models with external data sources, APIs, tools, databases, vector stores, and custom business logic. Instead of thinking of LangChain as another AI model, think of it as the software framework that helps AI interact with the real world. Why LangChain was created? Real world AI applications require much more than simply generating text. Most production systems need several steps. First, they receive user input. Next, they prepare prompts. Then, they query an LLM. After that, they retrieve external information if necessary. They may call APIs, search databases, execute code, or perform calculations. Finally, they format the response for the user. Managing all these steps manually quickly becomes uh, complicated. Langchain provides usable components that simplify this entire flow. It lets developers focus on building applications instead of repeatedly writing infrastructure code. This is one of the main reasons Langchain became popular shortly after the rapid growth of large language models. Installing Langchain. Langchain is available for Python and JavaScript. For Python, installation is straightforward using pip. The core package provides the framework itself, while integrations such as OpenAI, Anthropic, Google, vector databases, and embedding models are installed separately. This modular architecture keeps projects lightweight because you only install the integrations you actually need. Always refer to the official Langchain documentation for the latest installation instructions because package names and integrations evolve over time. The core components. To understand Langchain, You need to know its main building blocks. The first component is the language model. Langchain supports many providers instead of being tied to one company. Developers can work with OpenAI models, Anthropic models, Google Gemini models, OpenWeight models, and many others through integrations. The second component is prompts. A prompt is much more than a simple question. It defines the instructions, context, formatting, constraints, and examples that guide the model's behavior. Langchain includes prompt templates that allow developers to dynamically insert variables into prompts instead of manually building strings every time. The third component is output parsing. Language models naturally produce text, but applications often require structured outputs such as JSON or specific fields. Output parsers help convert model responses into predictable formats that software can process reliably. Chains. The word chain is part of Langchain's name because of the framework is designed around connecting multiple operations together. Imagine an application that performs the following sequence. User asks a question, application retrieves relevant documents. Documents are inserted into a prompt. Prompt is sent to an LLM. The response is formatted. Each step depends on the previous one. Together, these connected steps form a chain. Modern Langchain development also uses the Langchain expression language, which provides a consistent way to compose these processing steps into pipelines. Chains make AI applications easier to understand, maintain, and extend. Retrieval augmented generation. One of the most important concepts in modern AI development is retrieval augmented generation, commonly called RAG. Language models do not automatically know your company's documents, research papers, internal policies, or personal notes. Instead of retraining the model every time new information appears, RAG retrieves relevant documents at runtime. The workflow is straightforward. Documents are divided into smaller chunks. These chunks are converted into vectored embeddings. The embeddings are stored in a vector database. When a user asks a question, the application converts the question into an embedding and searches for similar document chunks. Only the most relevant information is added to the prompt before sending it to the language model. The model then generates an answer based on both its general knowledge and the retrieved context. This approach improves accuracy while reducing hallucinations because the model has access to relevant supporting information. Next chapter is embeddings and vector databases. Embeddings are numerical representations of text that capture semantic meaning. Instead of comparing exact words, embeddings allow computers to compare meanings. For example, sentences discussing automobiles and cars may have similar embeddings even if they use different words. Vector databases store these embeddings efficiently and allow similarity searches. Popular vector databases include Chroma, Pinecone, Weaviate, Milvus, and Fies. These databases play a central role in RAG systems because they enable fast retrieval of relevant information. Next is tools and agents. Another major capability of Langchain is connecting large language models into with tools. A tool can be almost anything. It may perform mathematical calculations, search the web, query a database, execute Python code, access a weather service, read files, or interact with external APIs. An agent is an application that uses a language model to decide which tool should be used for a particular task. For example, if the user asks for today's weather, the agent can decide to call a weather app API instead of trying to generate an answer from memory. If the user asks for a mathematical calculation, the agent may choose a calculator tool. The language model reasons about the problem while the tools perform the actual actions. Many AI applications. Now the memory is the next point, next chapter. Many AI applications involve conversations rather than single questions. Memory allows applications to maintain context across interactions. Instead of creating every message independently, the application can reference earlier parts of the conversation when generating new responses. The exact memory strategy depends on the application's requirements, such as retaining recent messages, summarizing older conversations, or storing long-term user information. Putting everything together, let's review the complete architecture. The user submits a question, application prepares a prompt, if external knowledge is needed, the retriever searches a vector database, relevant documents are added to the prompt, the language model generates a response. If actions are required, an agent selects appropriate tools. Final answer is returned to the user. This combination of prompts, retrieval tools, chains, and language models forms the foundation of many modern AI applications. Conclusion. Congratulations on making it to the end of this complete introduction to Langchain. Today we learned what Langchain is, why it exists, its core components, prompt templates, chains, retrieval augmented generation, embeddings, vector databases, tools, agents, and memory. Remember that Langchain is not a language model itself, it is a framework that helps developers build applications powered by large language models by connecting them with external data, tools, and workflows. If you enjoyed this video, don't forget to like, subscribe, and share it with anyone learning AI development. Thank you for watching, and I'll see you in the next one.